Alright, we are going to try something new today so you can actually see me. I want to go through the homework that was due from Tuesday. I looked through some of yours submissions, and some of you had it, some of you don't have it yet. The first thing you need to do is get the identity sheet that's in your folder from Tuesday. I think I'm going to also put it in for today in the Thursdays thing, but the fundamental trig identities, all of those are listed on that sheet. You should have this in front of you at all times as you're trying to go through these. Basically, we're not going to move on today. We're going to go through a few of the problems that you had from Tuesday and give you a few more to try. But thought I would try to do it this way just so that you can see me doing it a little bit better than just going on the Schoology site. All right, first one was that you were given tangent theta was 3/4 and sine of theta was greater than 0. Basically from our all spiders taste crunchy. Right? Tangent's positive, that happens in quad 1 and quad 3. Sine is also positive in quad 1 and quad 2. So right now we're in quadrant number 1. So basically that tells us that all trig functions are going to end up being positive for this. All right? So we had to find the other 5 trig functions. Cotangent theta is going to be just the reciprocal using our reciprocal identities, so that ends up being 4/3. So you can find the first one pretty easy just doing that. Next, I told you on Tuesday that you want to try to stay in the Pythagorean identities, at least initially. I have a tangent already, so in my Pythagoreans I have 1 plus tan squared theta equals secant squared theta. All right, so I'm going to use that one, okay, and replace the tangent with 3/4. So I'm going to have 1 plus, take out the tangent, replace it with 3/4. That's still being squared, equals secant squared. 3/4 squared is 9/16. Now when I'm adding these fractions here, this one's going to turn into 16/16, which turns into 25/16. And then we're going to square root both sides, so we get 5/4 for secant. Now when you square root both sides, you have to have plus or minus, but remember we're in quadrant 1, so everything's positive, therefore secant is going to be 5/4. Next, its buddy is cosine. So cosine is just going to be the reciprocal of that, so it should be 4/5. Right? I noticed some of you thought using your quotient identity, tangent was sine over cosine. So some of you just put sine was 3 and cosine's 4. Can't use it that way. All right? Had to end up going with our Pythagorean identities here. All right, so we have 4 out of the 6 right now. All right, we still have to find sine, and I have a cosine. My favorite, once I have either a sine or cosine, is to go into that bottom 2 Pythagorean. So sine squared x, or theta, is equal to 1 minus cosine squared theta. All right, so again, that's our Pythagorean identity. I already have cosine. So my cosine was 4/5. So I replace the cosine with 4/5. Still have to square it. Sine squared theta equals 1 minus 4/5 squared is 16/25. Again, this one's going to turn into 25 over 25. So sine squared theta is equal to 9 over 25, and then square root both sides, and I get 3/5 for that one. Again, positive because we're quad 1. And last but not least, cosecant theta, just the reciprocal of that, 5/3. All right, so that should have been number 1. Again, given one trig function here, okay, given us where sine is going to be located, that helps us find out what quadrant you're in. Usually or typically when I'm going to give you just one trig function, you're going to have to use two different identities to help you find the remaining five. All right. A lot of times you'll be able to get the reciprocals, right? And somebody else could have chose something else. Cotangent, you could have done 1 plus cotangent squared equals cosecant squared. You could have found it that direction first. So there is some play with who wants to do what first, all right? But it is totally your choice as long as you have one of those trig functions. All right, give me a second here. I'll erase that and be right back with you.